Hello everyone. As you know, yesterday, that is 29th of September, UPSC conducted means optional subject, and we are going to take mathematics optional. And I hope your examination was good. What was the kind of question? Obviously, some of the questions were repeated, concepts were repeated, some of the questions were not in the textbooks. So today I am going to take up a whole series for the detailed solution of paper 1 and paper 2, but in this video particularly I am going to focus on ordinary differential equation. How many marks it was asked for? It was asked for 70 marks, but last year it was 106 marks. And it is imperative that we must understand what is the contour of the examination that is demanding in this paper. So I will be running the lecture series topical wise, and today we are going to take ordinary differential equation, which was asked in civil services mains examination. So first question that is this question, that is we have to solve this 2y sine x plus 3y4 sine x cos x dx minus of 4y cube cos square x plus cos x dy is equal to 0, 10 marks. In our previous lectures also on our channel, we have emphasized and underscored the understanding that the most focal area is integrating factor. So prima facie, this question appears to be of integrating factor. That is, if I write this as our solution, and if we compare m dx plus n of dy is equal to 0, first and foremost thing is what we do is that we write our dou m by dou y. So here m is 2y sine x plus 3y to the power 4 sine x cos x. So if I take the derivative with respect to y partially, it is going to be 2 sine of x plus 12y cube sine x cos x. Alright. Now we will take our partial derivative with respect to x, that is dou n by dou x. So minus sign is already outside, so I will keep it outside. Now if I take the derivative partially cos square x, this becomes minus of 8y cube cos x sin x, and the derivative of cos x is minus sin x. So we can take this minus inside and make the whole term as positive. Now we can see that dou m by dou y is not equal to dou n by dou x. So what we will do, we will try to find out the integrating factor, that is dou m by dou y minus of dou n by dou x. So this is 12 and this is 8. So 12 minus 8 is 4 y cube cos x sin x. This is 2 times and this is 1. So this will be sine of x. Okay. So if we take sin x, we can see it is in common, so we can take that in common. So this becomes sin x 4 y cube cos x plus 1. And now if I write this as 1 by n, which is the standard format of finding integrating factor, then we can see here that 4y cube cos x plus 1, if we take cos outside, that is common. So this becomes sin x 4y cube cos x plus 1, and if we take here from here minus cos outside, so this becomes 4y cube cos x plus 1. So we have got our integrating factor. So this is our minus of tan x, and our integrating factor is e to the power integral of 1 by n dou m by dou y minus dou n by dou x. dx. So this value whole is minus of tan x. So we can write it on the upper portion. Our integrating factor as e to the power minus tan x by dx. So we can write it as e to the power minus sin x by cos x dx. If we put cos of x is equal to t, we get minus of sin x dx is equal to dt. So we get e to the power minus of, so this minus sin x dx dt, we can write it as dt divided by t. So this is equal to e to the power ln of t. So we can write this as t, and t is our cos x. So we have got our integrating factor as cos x. What we will do, we have to multiply the integrating factor thoroughly in this equation. When we do so, this becomes 2y sin x cos x plus 3y to the power 4 sin x cos square x dx minus sin 4y cube cos cube x plus cos square x dy is equal to 0. Now this has become exact by this virtue of this integrating factor. So we will plug this one and this one and this one and this one, then it will be of exact form. So I can write this as minus sin of cos square x dy minus 2y sin x cos x dx. Again I am taking the minus sign common, so this becomes a 4y cube cos cube x dy minus of 3y4 sin x cos square x dx is equal to 0. Okay, so this has become the exact form, and we can write it as derivative of y cos square of x minus of d y to the power 4 and cos cube of x, because we have arranged it in terms of exact form. So we can write our answer by integrating on both sides. We can write y cos square x plus y to the power 4 cos cube x is equal to a constant. We have taken the minus sign on RHS. So this is our answer. I have not gone through that method called as integral of y is keeping as constant m dx plus n dy terms containing only y. This is the standard thing that is given in the book, but this can be lengthy, but normally this is an elegant way of writing it, because the whole purpose of integrating factor is to make the equation exact, and once we know that equation exact, there will be a rearrangement that will give us exact form, and then we can take the derivative and integral. So this is our answer for question number 5a. This was asked for compulsory question for 10 marks in 2019. Now I am going to take the next question. So this is question 5b, which was also asked in compulsory. That is asking us to determine complete solution of ODE d square y by dx square minus 4 dy by dx plus 4y is equal to 3x square e to the power 2x sine 2x, and again this is a 10 marks question. So we have to first find the complementary function and then particular integral. So here there are a lot of ways to do this question. I think the most important one which will take less time. So I am beginning with a solution, that is, we can write this as d square minus 4 of d plus 4d y is equal to 3x square e to the power 2x sine 2x. So first we have to find the auxiliary equation, that is m square minus 4m plus 4 is equal to 0. So this is our m minus 2 whole square is equal to 0. So here roots are repeated, so its complementary function is c1 plus c2x e to the power 2x. Now we have to find the particular integral. So particular integral can be written as 3 times x square e to the power 2x sine of 2x divided by d minus 2 whole square. Now here we have 3 functions: algebraic, exponential and trigonometric. So we will use the shifting property, and we can write this as, we can write this d plus 2 minus of 2, because we have shifted by this amplitude of exponential function. So this becomes e to the power 2x 3 times x square sine 2x divided by d square. So I am going to keep 3 e to the power 2x outside, and I will use the operator, that is 1 by d square. That means I am going to find it, the integral of this, twice. So if I write here 1 by d x square sine of 2x, that is going to give us integral of x square sine 2 of x. So if we integrate this by part, we can write it as x square, integration of sine is minus cos, and there is an argument, so we will divide it. So minus of 2 times of this integral, because we are differentiating it, and this becomes cos 2x, and minus sign of this become plus, divided by 2. So we can cancel this one out. So we can write this as x square cos 2x divided by 2 plus, again we will use the integration part. We are going to keep x constant, and this integral is sin 2x by 2 minus of integration of again sin 2x by 2, and differentiation of x is 1. So we get this as x square cos 2x divided by 2 plus x sin 2x divided by 2, and the integration of sine is minus cos, so minus minus become plus, and we have to divide by 2, so this becomes cos 2x by 4. Okay, so we can club this one and this one, so we can write cos 2x divided by 4. If we write here, this becomes 1 minus 2 x square plus x sine of 2x divided by 2. Alright, so we have found this integral one time, we have to find it one more time. So we have to find it one more time. So this will give us integration of cos 2x divided by 4 into 1 minus 2x square dx plus integral of x sine 2x divided by 2 dx. So now I am going to integrate this by parts. So this becomes if we take this integral, this becomes sine 2x divided by 8 into 1 minus 2 square minus of sine 2x divided by 8 into minus minus becomes here plus. So this can be written as 4 of x dx plus integral of x sine 2x divided by 2 dx. So we get this as sine of 2x divided by 8 into 1 minus 2x square, and this becomes x by 2. So x by 2 sine, so these are common, so we can write it as integral of x sine 2x dx. So I can write on the upper portion so this can be written as sine 2x divided by 8 1 minus 2x square. Now we will integrate this one by parts. So this is our how much? We can write it as x as constant, and we can find its integral divided by 2, and this is again plus plus become minus minus become plus. So this becomes cos 2x divided by 2 dx. So you can write this as sine 2x divided by 8 to 1 minus 2x square x cos 2x divided by 2, and integral of cos 2x can be written as sine 2x divided by 4. So we have got here the value for this one. So we can further simplify it. We can see here sine 2x divided by 8, this can be written as 3 minus 2x square minus x cos 2x divided by 2. So we have found this one. All we have to do is now multiply by 3 into e to the power 2x, and we will get our answer. So you can write this as 3 times e to the power 2x cos 2x divided by 4, and here this is the one that we are copying. This is the value that we have got, not this one. So this can be written as 3 times e to the power 2x, this is our sine 2x divided by 8, 3 minus 2x square minus of x by 2 cos 2x. So if we take here 3 by 8, if we take 8 outside, we can write this as sine of 2x into 3 minus 2x minus of 4x cos 2x. So this is our particular integral. So the answer is y is equal to c1 plus c2 x e to the power 2x. If we take minus sign as common, so we can revert it as sine 2x square minus of 3 plus 4x cos 2x. Well, this solution may seem quite unorthodox, not given in many of the books, but this is also one of the way of doing it. There is an alternative method to do from here on. That is, I'll just write the formula. We can write this as 3 e to the power 2x into integrating factor of e to the power 2ix x square divided by d, and we will, because we are taking sine 2x, so that is imaginary part of e to the power 2x. So this is also the method that can be, through which it can be solved. That is, we can write it as x square, we can take 2i square common, 1 plus di whole square, and then we can proceed and find by using this formula 1 minus x, or 1 plus 2x plus 3x square. So this is not still in that format, and we will get our answer. This can be written as minus of 4. This can be written as d by 2i. So this has come in this format, and if you will decompose it for this term, because after this is vanishing, so then also we are going to get the same answer. So this is 3 by 4 e to the power 2x into 1 integrating factor of 2ix into x square into 1 plus 2 times of d by 2i minus of 3. This is I, because the I square is minus, and we can find the answer. The answer will be the same to this question. Now we are going to take the next question. So the next question is question number 6C1, and it asks for 10 marks. We have to solve this differential equation d square y by dx square plus 3 sin x minus cot x dy by dx plus 2y sin square x is equal to e to the power minus cos sin square x. This is a second order differential equation. Before I start solving this question, it is important to understand as to how to find which method to be used. Here, first and immediate thing that we must write is write our P, Q and R. And here we will find something. Here in Q, we are having this sin x square as perfect square. So we have the clue that what we have to do. So we can write is, we have to choose dz by dx square is equal to sin square x, because we are changing the independent variable in this method. So this is the algorithm for this. So this can be written as dz by dx is equal to sin of x, and z can be written as, if we integrate this becomes z is equal to minus of cos x, and d square z by dx square is going to be cos of x. So here we know our P, that is 3 sin x minus cot square x, cot x, and Q is 2 sin square x, and R is e to the power minus cos sin square x. So we have got our Q with this respect. So we have to change the independent variable. So how do we do that? D square y by dz square plus P1 dy by dz plus Q1 y is equal to R1. In examination, we do not need to prove this. If it is specifically asked how this transformation changed, then only you have to write it. So here P1 is going to be d square z by dx square plus P of dz by dx divided by dz by dx whole square. So our d square z by dx square is, we can write it from here, this is our cos, and here we are having our P, that is 3 sin of x minus cot of x, and we can write this as dz by dx. So dz by dx is sin x divided by sin square x, because its value is sin square x. So here we can further simplify and write this as cos x plus 3 sin square x minus of cot into sin is cos. So this one and this one get cancelled and we are left with only 3. So we get P1 as 3. Similarly, we have to find Q1 and its value is Q by dz by dx whole square. So what is the value of Q here? We have to write this is 2 sin square x by sin square x. So this is the coefficient, that is Q1 is R2. Then what is the value of R1? R1 value is R by dz by dx whole square. So R value is e to the power minus of cos x sin square x divided by this value is again sin square x. So this one get cancelled. So we can write it as e to the power cos x. But remember, this is in terms of x. We have to change the independent variable to z. So we will write it as e to the power. What is the value of z? Z is minus cos x. So in place of minus cos x, we can write z. Now we have got our P, Q and R. So this can be written as d square y by dz square plus 3 dy by dz plus 2y is equal to R1. R1 is our e to the power z. So now we can solve this second order differential equation. Now it is having constant coefficient, as we can see from our equation. So this can be easily solvable. And here, what is the complementary function? If we write it as d square plus 3d plus 2y is equal to e to the power z. So you can see our auxiliary equation is m square plus 3m plus 2 is equal to 0. So we can write it as m plus 1 into m plus 2 is equal to 0. So our roots are minus 1 and minus 2. And with this respect to z, so we can write it as y is equal to c1 e to the power minus of z plus c2 e to the power minus of 2z. Similarly, we have to find the particular integral. So this is our e to the power z divided by d plus 1 into d plus 2. So here the coefficient is 1, so we'll put it here. So this becomes e to the power z. This is 1 plus 1 2 and 1 plus 2 3. So 2 into 3 is 6. So we get our answer y is equal to c1 e to the power minus z plus c2 e to the power minus 2z plus e to the power z divided by 6. Now our work is to transform back into x. So we know y is equal to c1 e and we know the z value is minus cos. So minus minus become plus. Similarly over here this become 2 times cos of x, and in place of z we can write e to the power minus cos x by 6. So this is our answer to this question. This was not a non-compulsory question, this was a non-compulsory question, and it demands us to find as to what is the method that we have to employ. We can readily see from here. So we know the methods right, and if we know the formulas we can get our answer correct. Now the next question. So the question is question number 6c2, and we have to find the Laplace transform of t to the power minus half and t to the power half. And after that we have to prove that the Laplace transform of t to the power n plus half, where n belongs to n, is gamma of n plus 1 plus half divided by s to the power n plus 1 plus half. Now this question, when we have to find the Laplace transform of t to the power half minus half, this we have solved on our lecture series on Laplace transform, that is lecture number 2 on Laplace transform. We have solved this question from the basic fundamental definition. So we are going to find for this one. If you want to see from the fundamentals, you can watch our video number 2 on Laplace transform, and its answer is root pi by s. Now we have to find the Laplace transform of t to the power t half. We can also do it through the fundamental definition, but here we can directly use a formula because it's only asked for 10 marks. This is the formula for n. So for Laplace transform of t to the power of half is gamma of half plus 1, and this is our half plus 1. So we know that gamma n plus 1 is equal to n into gamma n. So here we can write this as half into gamma half, and this as s to the power 3 by 2. And we already know the value of gamma half is root pi. So this value amounts to 1 by 2 gamma half value is root pi, and this is our s to the power 3 by 2. So we got our value by using the formula. Now, but for this one we have to use the fundamental definition. So we are going to write it over here. If we write the Laplace transform of t to the power half n plus half into the fundamental definition, this is 0 to infinity e to the power minus s of t into t n plus half dt. Now first and foremost is that we have to integrate this. We can do it by integration of part, but for quick results we can put s of t is equal to u. So this gives us dt is equal to du by ds, and our t will be u by s. So we can write Laplace transform of t plus half is equal to 0 to infinity e to the, in place of st we can write straight away u, and in place of t we can write u by s to the power n plus half. And what is the value of dt? Dt value is du by dx. So this is du by dx. So we can take all our s outside. We can write this as n plus half. This is, if we take it outside, it becomes n plus half plus 1. Alright, now we know gamma of n is equal to 0 to infinity e to the power x s to the power n minus 1 dx. Alright, so here we are getting it as n plus 1 plus half, and here if we write u n plus half plus 1 and we subtract by 1, then this is on this of this format. So we can straight away write this as gamma of n plus half plus 1 divided by s to the power n plus 1 plus half. So this is what we have to prove. So we have covered the Laplace transform on great detail, all the questions and all the type of questions that have been asked in civil services and the general theory. You can refer to those videos. Now I'm going to take the next question. So question number 7a reads that you have to find the linearly independent solution of corresponding homogeneous differential equation of the equation x square y double dash minus 2x y dash plus 2y is equal to x cube sine of x, and we have to also find the general solution by variation of parameter. This was asked for 15 marks. There are two approaches to this. One is by finding a part of the solution, and other is by Euler-Cauchy equation. We can find the complementary function and then use that to find the variation of parameters. So we have, this is of 15 marks, so I will write the standard equation y double dash minus of 2 by x y dash plus 2 by x square y is equal to x by sine x. This is the standard format of writing second order differential equation, and if we compare with the standard result of second order differential equation, then we get our P as minus of 2 by x and Q as 2 by x square. So we can see here, if we write P plus Qx, we get 0. So that means that x is a part of a solution. So y is equal to x is a part of solution. So we can write this as y is equal to v of x. So if we take dy by dx, we will get v plus x dv by dx. Similarly, if we take again derivative, then this will become d square y by dx square is equal to x d square v by dx square plus dv by dx. So one time I have kept dv by dx constant, this become 1, so this is dv by dx and plus dv by dx. So this gives us 2 times of dv by dx. Now we can put this into the original equation. So this gives us x d square v by dx square plus 2 dv by dx minus of 2 by x. We have to put the value of dy by dx. This is v plus x dv by dx plus 2 by x square, and value of y is vx, and since we are finding complementary function, we are putting on that is equal to 0. So we get our x d square v by dx square. We can see here that 2 dv by dx, and this one is 2 dv by dx, and this is minus of v by x, this is 2v of x. So this one and this one get cancelled. So we get this as x d square v by x square is equal to 0. So we can write dv by square is equal to 0. So if we are going to integrate, we will get dv by dx is equal to, say, a constant c2, and our v is going to be c2 x plus c1 again. So we have got our v is equal to c2x plus c1. Now we can find our y. So y is equal to v by x. So this gives us c1x plus c2x square. So we have got the complementary function, and this can be said to be the solution of general solution, and we are going to find it by variation of parameters. So we have got our y. So y is c1x plus c2x square. So now we have to use the method of variation of parameters. So for this we have to find that, we have to let that y is equal to x plus bx square is part of solution, and where we choose u is equal to x and v is equal to x square, and u dash is 1 and v dash is 2x, and we have to compute the Wronskian, that is u v u dash v dash. So this gives us x square 1 2x. So this gives us Wronskian as 2x square minus x square is equal to x square, which is not equal to 0. So now we will find the value of a and b. A can be written as minus sign of this r, that is x sine x, divided by w, that is our x square, into v, that is x square, and this gives us, so this one and this one get cancelled. Now we will keep the minus sign outside, and we are going to integrate this by part. So if we write this, this will become x cos of x, minus become plus, so this become cos x dx plus, say, constant k1. So we get our A as x cos x, and integration of sine is cos is sine. So this becomes sine of x plus k1. Alright, similarly we are going to find b. So b is going to be integral of u is our x into r is x sine of x divided by w. This is, so this one get cancelled. So we get our b as minus of cos x plus k2. All we have to do, we have to put the value of a1 and b in this equation. So this gives us y is equal to x into x cos x minus sine of x plus k1 plus b is k2 minus of cos x into x square. So here we can write this as k1x plus k2 x square, because this has come in the complementary function, and this can be written as x square cos of x minus of x sin x, and this is x square cos x. So this one and this one get cancelled, and finally we are left with y is equal to k1x plus k2x square minus of x sin x. This is our answer. This question could also be asked by using Euler's Cauchy equation. There also such kind of this same question may be repeated next year, and that is a lengthy question, and that will require us to understand lot of different concepts. I will just give you a simple illustration. That is, if you put x is equal to e to the power t, then this becomes d dash minus 1 minus of 2 d dash plus 2 y, and this can be written as e to the power 3t sine of e to the power t. So we get this as d square minus d dash square into y, and here this become integral, become different. So this can also be solved by this method if it is asked to do so. So now I am going to take the final question that is asked in this examination. So the question is question number 80 that appeared in examination, that is asking us to obtain singular solution of dy by dx whole square y by x whole square cot square alpha minus 2 dy by dx into y by x plus y by x whole square cos square x alpha is equal to 1. We have to find complete primitive of the given differential equation and also give the geometrical interpretation of the complete primitive and singular solution. So how do we go about this question? First of all, we have to find the general solution and also the singular solution, and also find the geometrical interpretation of singular solution as well as the general solution. So first of all, we are given this as dy by dx whole square y by x whole square cot square alpha minus of 2 dy by dx into y by x plus y by x whole square cos square alpha is equal to 1. So it is quite apparent that this is homogeneous. So what we will do, we will try to simplify this equation. That is, we will multiply by x square tan square alpha throughout. So we are going to get dy by dx whole square into y square, x square and x square get cancelled, cot square and tan square get cancelled. This is 2 dy by dx, I can write x square, so this become x of y, and here we can write this as tan square alpha, plus over here we can write this as y square, x square and x square get cancelled, and tan square alpha and cos square alpha is our sec square alpha is equal to, we have to multiply here also, so this becomes, if we bring on this side LHS, so this becomes x square tan square alpha is equal to 0. So we have got our p square y square minus 2p y x tan square alpha plus y square sec square alpha minus x square tan square alpha. So we can write this as p of y is equal to 2 times x tan square alpha plus minus under root of the square of this one. Square of this one is 4 x square tan to the power 4 minus of 4 into y square sec square alpha minus x square tan square alpha divided by 2, because we have already factored this into, and where p is dy by dx. So we can write this as py is equal to how much? This will be x tan square alpha. Now we can take the 4 outside, and that will also be cancelled out. So here we see here x square tan to the power 4 alpha, and this minus minus become plus. So I can take this as common, tan square alpha plus 1 minus of y square sec square alpha. So we have got py in terms of this. So you can further simplify, this become py is equal to x tan square alpha. We can write this as, you can take the sec outside, this is sec square, this is sec square, so when it will come outside this will become sec alpha, and this becomes x square tan square alpha minus of y square. So we have got this. We can write p as dy by dx. So we can write over here, that will be y dy, and if we take whole on this side, this become x tan square x d of x, because we are bringing on this side, and this will be equal to plus minus sec alpha dx, and the whole, this part we are bringing on this side, so this become x square tan square y tan square alpha minus of y square. Alright, so we can see here we have taken on this side, that is y dy minus of x tan square alpha, and we have kept this one as constant plus minus, and sec square dx is taken, and this is taken in the denominator. So we can bring this side over here, and we can write this as minus, and if we put x square tan square alpha minus y square is equal to say t square, then we get 2x tan square alpha dx minus 2y dy. So this is the minus sign of this, so we have sent the minus sign over here. So this becomes plus minus integral of t dt divided by, this is t squared, so under root is t, is equal to sec alpha d of x. So this one and this one will cancel, so we will get this as under root of x square tan square alpha minus of y square is equal to, if we integrate on this side, this become c minus sec alpha into x. So if we take the square of this, we will get it as x square tan square y minus of y square, and this is c square minus of 2cx sec alpha plus x square sec square. So if we take all of this on this side, we can see x square sec square alpha minus tan square alpha minus of 2c x sec alpha plus of y square. So we have got this as x square, this is 1, and this is our 2cx sec alpha plus y square, and we have forgotten here c square. So we have got this is the equation of circle. So the general format for this, so we have got this as the equation of circle. Now we will find the p discriminant and d discriminant for both of these to find the singular solution. First I will proceed with finding the c discriminant. So here we can see c square minus 2cx sec alpha plus x square plus y square is equal to 0. So this is the thing, this is the equation. So we will find the c discriminant over here. So I will write at the top what will be our c discriminant. So the c discriminant is going to be 4x square sec square alpha minus of 4x square. So we can write this as x square sec square alpha minus of 1 minus of y is equal to 0. So we get this as x square tan alpha square minus of y square is equal to. So this is our c discriminant. Still we are not clear what is our singular solution. So now we have to find the p discriminant. Find the p discriminant, we have to write in terms of, if I write this as dy by dx and I write this as cos square minus of 2 dy by dx. So this will become sin square plus this will become y square minus of x square sin square alpha. So we have to write it in such a manner, we have to write here 2x y is left, and we can find our p discriminant. So when we will compute, that will be 4y square to x square sin square alpha minus of y square alpha. So here we can see these things are going to, here it is x square sin square alpha minus of y square cos square alpha. If we compute the p discriminant over here, so this gives us x square tan square alpha minus of y square is equal to 0. So we are clear that y is equal to 0 is tac locus, and singular solution is x tan alpha y is equal to plus minus x tan alpha. So our general solution was a circle lying on x axis, as we have done in this one, and the singular solution is any line passing through this at the slope tan alpha which is equally inclined. So this question could have also been done by taking y square is equal to capital Y and x square is equal to capital X. That also could have all been done, but that would have further complicated the matter. We could have to use a homogeneous again, and then the equation will become a bit lengthy. So this is the general format for the answer. So we have done with the ordinary differential equation for 2019. Thank you for watching. Please like, share and comment, and if you have any clarification, please feel free to ask. Thank you once more.